So I want to talk to you about composite functions here. You already know some function notation. We've got three functions here, f of x, g of x, h of x. We're going to talk about composite functions. And a composite function is a function of a function inside of another function. Now before I get into composite functions, just a reminder that using f of x as an example, if I write f of 3, what that's saying is substitute the number 3 in for x, wherever x appears in your function. So f of 3 is equal to 2 times 3 minus 5, which is equal to 1. So f of 3 is equal to 1 if f of x is 2x minus 5. I could also do this for h of x. If I said h of 4, that says substitute the number 4 in wherever 4 appears, wherever x appears. So that's 2, 4 squared, minus 3 times 4 plus 2. That's 16 times 2, which is 32, minus 12 plus 2, 22. So we can say if h of x is 2x squared minus 3x plus 2, then h of 4 is equal to 22. Whatever that is, we substitute. What has this got to do with functions? Well, now we're not going to, or composite functions, we're not going to insert a number into these functions. We're going to insert a whole function into these functions. Example. So if this said f of 3, this says g of f of x. We're going to insert the function f of x into g of x. So g of x is 3x plus 5. And I'm going to insert the function f of x in here. Three times f of x plus 5. What's f of x? Well, f of x is 2x minus 5. So it's 3 times 2x minus 5 plus 5. That's going to be 6x minus 15 plus 5. 6x minus 10. So we have a new function. That's the great thing about composite functions. We've got f of x, g of x, h of x, and now we have a new function called g of f of x. And g of f of x is equal to 6x minus 10. It's a combo of these two functions. Let's do one that's way more complicated. H of f of x, or sorry, h of f of x. So, the function h of x is 2x squared minus 3x plus 2. And everywhere where an x appears, we're going to have to replace that with the function f of x. So it's going to be 2 times f of x squared minus 3 times f of x plus 2. Look at those brackets. That's a smaller bracket there around the f of x. Okay, now let's dump f of x into there. 2 bracket f of x is 2x minus 5 minus 3 2x minus 5 plus 2. Alright, now we've got to square that. That's a perfect square. So it's going to be 2 bracket 4x squared minus 20x plus 25. We've got to use our distributive law here, minus 6x plus 15 plus 2. We've got to multiply everything in there by 2. 8x squared minus 40x plus 50 minus 6x plus 15 plus 2. Now we've got to group our like terms. We've got a negative 40x, we've got a negative 60x, and we've got a positive 50, a positive 15, and a positive 2, and we've got this guy out the front. 8x squared minus 40x minus 6x, that's minus 46x, positive 50, positive 15, positive 2, that's plus 67. That's it. So, now we know that f of x is 2x minus 5, h of x is 2x squared minus 3x plus 2, and h of f of x is 8x squared minus 46x plus 67. So that's really all there is to composite functions, dumping one function in another function. It can get really simple like this, where you're dealing with two linear equations put inside of each other. It can get quite complicated like this, where you're dumping a linear equation into a quadratic function. It could even get really crazy if we had another function, I of x, which was another quadratic function, and you were dumping a quadratic function into a quadratic function. Alright, but there's your process. Follow that process. It really doesn't matter how difficult or complicated the functions are. You just need to work through them step by step.